My sweethearts, today we are going to talk a little bit more about factoring, right? So how can we use the distributive property to factor the expression? So we've got this expression here, 6 times some unknown number, we're calling it x, plus 15, okay? And what we want to do is we want to factor this out. It's a distributive property in reverse. So just like what it sounds like, we need to look for factors, okay, between our, in this case, our coefficient and our constant, right? So we need to think about what are our factors of 6 and 15. So you could use a ladder, the ladder method like you learned about yesterday. I prefer to just kind of simply write them out. That's just my preference, right? You are obviously able to do whatever is going to work best for you. And with factoring, right, we're looking at whole numbers. We are not looking at fractions and decimals. So just whole numbers that can multiply in order to equal the number that you are looking for. So after we have our factors, then we want to look for our greatest common factor. In this case, it is 3. So what that means is I can pull out, I can divide, I can factor this expression, right? I can actually take each term, my 6x and my positive 15, I can divide each of those by 3. Now, when I do 6x divided by 3, I am left with 2x. And when I do positive 15 divided by 3, I'm left with a positive 5. Now, since I pulled the 3, I factored the 3, I divided by 3, I'm going to indicate that here. And again, it's a distributive property in reverse, right? If I gave this to you, you would be able to tell me, right, because I've seen you work on this throughout the week, that 3 times 2x is 6x, and that 3 times that positive 5 is positive 15, okay? So that's how we can double check our work to know that this is our factored out expression. All right, let's look at another one. So we have Sahil's putting together supply kits. Has 36 packs of X pencils, right? So 36 packs of X, 12 packs of Y crayons, and 24 erasers, okay? Now, notice, right, 36 packs of X, we don't know how many pencils are in each pack. We also don't know how many crayons are in each pack. We do know that there are 24 erasers. So now we need to write an expression to show the total number of items. Well, if we're talking about total, what operation are we talking about? Right, so we're talking about adding these. 36 packs of X can be represented as 36x. Again, we're adding because we're looking for total. 12 packs of Y crayons can be represented as 12Y. And then there really is no variable for the erasers. We know that there are just 24 erasers. So this becomes our expression to show the total number of items. This can't be simplified anymore, right? We can have no like terms that we can combine because we have different variables and then we have a constant term. So think about this for a moment, right? We just said we had 36x plus, oh, hold on, my old lady brain, 36x, 12y. Okay, there we go. All right, we said we had 36x plus 12y plus 24. Okay, now we're going to use factoring to show sorry for my grammar, how many kits Sahil can make while putting every type of item in each kit, right? Notice that it does not tell you to use the GCF because there are several different possibilities, right? I can look at 36, 12, and 24, and I can think about what are some factors of those three numbers. What factors do they share? Then I can pick one of those factors because it didn't tell me to use the greatest common factor. But let's say I want to, right? I want to make the most amount of kits possible. Well, the greatest common factor of 36, 12, and 24 is going to be 12. I can divide each term by 12. And again, we indicate this by, right, it doesn't just go away. We put it outside the parentheses because if we could reverse this and use the distributive property in order to check our work. 36x divided by 12 is going to give me 3 times x plus, well, 12 divided by 12 is 1. As a reminder, I don't need to write 1y. I'm just putting y. There's clearly one y there. 24 divided by 12 is going to give me 2. And there's a factored expression. But let's say she wants, or she or he would like to, it doesn't have to make the most amount of kits. He wants to see all the different options. Well, another factor between 36, 12, and 24 is 3, right? So we could make 3 packs. If they were to make 3 packs, they would have 12 packs of X amount of pencils and 4 packs with Y amount of crayons in them and 8 erasers. Okay, so there's different ways that we can factor to show how many kits they can make. And like I said, there were several different options for this. You could make 1 giant pack, right? You could make 2. You could make 6, right? There was 4. There's several different factors that 36, 12, and 24 share. All right, so looking at this, right, we have your friend incorrectly factors 15x minus 20xy as 5 times 3x minus 4xy. And I'm going to pause, right, because I want to see, why do you think this is incorrect? So when I look at these terms, right, I've got a 15 as a coefficient, I've got a 20 as a coefficient. Why, if 5 is the greatest common factor of 15 and 20, that is indisputable. So why is this incorrect? Right, so we are definitely looking at the 5, but there's another piece. There is another piece of this that is in common, right? Originally, we were looking at 15 times x minus 20 times xy, right? And we're looking for what's in common. What can be pulled out of both of these? What can be divided? What can be factored, right? It's not just the 5. Because if you were to do it like your friend did, you'll notice there's still something in common. There's still that x. We can absolutely factor that out. We could divide both of these terms by 5x. When we do that, 15x divided by 5x would leave us with 3. And 20xy, I should say negative 20xy, divided by 5x would leave us with a negative 4y. This is completely factored, okay? And again, I can double check my work. 5x times 3 does indeed give me 15x. 5x times negative 4y does indeed give me negative 20xy. All right, and how can negative 4x minus 8 be factored? Okay, and I'm going to show you, right? So there's actually two ways that you could factor this. Okay, and I want to kind of like let you think about that. Like, how do you think this could be factored? Because again, there's a couple ways, but let's talk first just about how could we factor this using, right? Using the greatest common factor of that, of the 4 and the 8, right? So let's think about that. So one way you could factor this is if you factored out positive 4. If you factored out positive 4, what would you be left with inside, right? If you divided out a positive 4 in both of these, what would you be left with? Well, you'd be left with negative x minus 2. There's another way that you could also factor this out. Because again, what do you notice, right? What do you notice is still in common, but inside your parentheses? Yeah, it's that negative sign, right? So you could, instead of factoring out positive 4, you could factor out a negative 4. And when you do that, now I'm dividing both terms by negative 4. Negative 4x divided by negative 4 leaves me a positive x. And negative 8 divided by negative 4 gives me positive 2. Now, let's go back and check just to make sure, right? We apply the distributive property because that's the inverse operation. 4 times negative x does indeed give me negative 4x. 4 times negative 2 does indeed give me negative 8. Okay, so this one checks out. It works. All right, let's try this one. Negative 4 times positive x. Yep, negative 4x. How about negative 4 times positive 2? You got it. That does indeed give me negative 8, which we can also represent as minus 8. So, yep, that one checks out as well. All right, guys, I hope that this helped. Let me know what questions you guys have. I love you, and I hope you have a wonderful day.